All right, here's one more example. And of course, if you have any questions, feel free to email me and I'll be happy to answer them. All right, so in this example, we're told that a media statistics agency reports that the mean number of televisions in a household in a particular country is 2.24. Assume that the population standard deviation number of television sets in this country is 1.38. So notice, first of all, we're not told if this is normally distributed or not. So basically, our shape is unknown. So we have to keep that in mind as we work through this problem. However, question or part A of this question doesn't even need to bother with that. It actually goes back to chapter 1 and reviews this idea of what type of variable is the number of television sets in a household. Well, we're counting a number of television sets, so it is quantitative because we can find the mean number, obviously. We're told that the mean number is 2.24, so it is quantitative. And regardless of whether you have a teeny tiny little portable TV that maybe has like a 4 or 5 inch screen, I used to have one of those and took it on road trips when I was a kid. It never got any stations because the antenna didn't work when I was traveling. But anyway, that's a different story. But it doesn't matter if it's that teeny tiny little travel TV or some giant 90-inch plasma screen. You can't have half of a TV. It might be super way smaller or 4 or 5 times as big, but it's still just one television. So we don't have any halves. We're counting, so that means that we have a discrete set of data. So it's quantitative and discrete. Okay, so again, remember we're told that we have a population mean of 2.24 televisions per household and a standard deviation of 1.38 televisions. Our next question actually goes back to chapter 3 a little bit and has to go to the idea of how do we find the mean. So this says a random sample of 40 households results in a total of 102 television sets. So what is the mean number of television sets in these 40 households? So basically, what is X bar? All right, so for the sake of being able to have a little bit of room to write, I'm going to write down what we had again. So we had a sample size of 40 households. And we have a total of 102 televisions. And so we're wanting to know what would be the sample mean for this sample of 40. Well, to find the mean, if I had the data, I would add up how many televisions in each household. Those would be 40 numbers I would add up. And what I'm being told is that when I do that, I get 102. So this is basically the sum of all of our data. So 102, and then when I divide that by 40, I believe I get 2.55. But let me triple check. I had that number up, and I've already cleared my calculator. So when I do 102 divided by 40, I divided by 4. 102 divided by 40, there we go. Yes, 2.55. If you hear barking in the background, my dogs are, I don't know, probably barking at a squirrel outside. So sorry, I apologize for that, and I hope it's not too loud. So there's our mean. That's what we're looking for in part B. So our sample mean for this number of this sample of 40 households is 2.55 televisions per household. All right, so final part of this question, part C. We're looking for a probability. Now, again, we've got a population where we know the mean number of televisions per household is 2.24, and the standard deviation is 1.38. In order for us to be able to find a probability like it's wanting us to do, we're going to have to make sure, since we don't know anything about the shape of the population, we've got to make sure that we have a sample size that's big enough. And fortunately, in Part B, we had a sample size of 40. So let me go over to a new screen so that I can show you all how we would work this out. All right, so here's all of our information. We know we have a sample of size 40. We know that our population mean is 2.24 televisions. We know that our population standard deviation is 1.38 televisions. And we found the sample mean to be 2.55. That was from Part B. And in Part C, we're being asked to find what's the probability of getting a sample mean greater than or equal to what we found in Part B. So greater than or equal to 2.55. Well, again, since my sample size is greater than or equal to 25, again, or greater than or equal to 30, it's bigger than both, then I can draw my normal curve, because central limit theorem says that as the sample size increases, the sampling distribution of the sample mean becomes more and more normal. So we're big enough to assume normality. My population mean will also be the mean of my sample means. So that's going to stay 2.24. My standard error for the sample means is going to be my standard deviation divided by the square root of the sample size. So again, that was back in, I think, Part 2 of our video, but that's what's going to happen anytime we're using the sampling distribution. And of course, I'm dealing with a sample of size 40. I'd like to mark that. So my standard deviation was 1.38. I'm going to divide that by the square root of 40. And once again, I know I've said it a few times now, I'm just going to leave it like that because I can put it in the calculator like that. So I don't need to figure out what value that is. The only time I have to do that is if the online homework says, what is the standard error? And it asks you to put in a decimal to 3 or 4 decimal places. Otherwise, just leave it like that because your calculator can handle it. Okay, and so now in order to shade this area that I'm trying to find, because remember, area and probability are the same, I want to mark 2.55. That's going to be somewhere over here to the right of 2.24 because it's a bigger number. And I want to have that value or more, so I'm going to shade to the right. So that's the area I'm looking for. So let me go grab my calculator screenshot. All right, and here we go. So I'll just slide that in right there. So just like we've been doing on the last example, I'm going to enter my lower, which in this case, again, is still that left-hand endpoint, the value of 2.55. My upper, since I'm going above, is 9999. If I were going the other direction, I would use negative 9999 and then whatever value. So if I was shading the other way, I would just want to use a negative value for the lower, a really big negative value. That sounds weird to say that, but really big absolute value, but with a negative in front of it. And then the number that I'm going up to, the stopping point, the right-hand endpoint would be my upper. And then again, I just put my numbers in, my mean of 2.24, my standard deviation divided by my sample size. So again, I just made sure that I didn't forget to include that part. And once I calculate, I will get my answer, and it's looking like we're getting, oops, keep it on highlighter, there we go. We're getting 0.0777. So it was 0.07769, but that 9 will round the 6 up to a 7. So there we go. That's our probability of getting this high, having 102 televisions or more from a random sample of 40 households. So what's the probability of getting that value like we got in part B? Okay, hopefully that helps. And again, if you have any other questions on the homework or the review, just let me know. I'll be more than happy to try and help explain further or differently, or just say it again. Whatever's going to help. Please just reach out. Thanks so much. Have a great day.